And these papers will be scrutinized by peers, and some of them will be selected for publication. Let me just briefly tell you about London Metropolitan University. We have a very long history. Our origins date to 1848, which is about 174 years ago. We are located in a number of campuses in London, and this campus is located on Holloway Road, which is next door to Arsenal Football Stadium. London Met offers a wide range of undergraduate and postgraduate courses, short courses, as well as professional qualifications. We are top 10 university in teaching quality. In fact, we are amongst the top 5 universities for research impact in mathematics. In the School of Communications and Digital Media, we have 2 centers, Cybersecurity Research Center and Communications Technology Research Center, and we're involved with research related to data analytics, AI, cybersecurity, forensics, IoT, wireless communications, robotics, as well as assistive technology. Other research areas include mathematics, journalism, and digital media. Please visit our website to see the full range of our courses and to see the PhD research opportunities. I'd like to thank a few people who helped in organizing this conference. Without them, this conference wouldn't have happened. They include our reviewers, committee members who did a lot of work behind the scenes. I also like to thank my team. They include Richard Sharma, Dion, Rino, Innocent. Thank you for the unwavering support. My special thanks goes to our Pro Vice Chancellor for Research and Knowledge Exchange, Professor Don McRaeld, and our Dean for School of Communications and Digital Media, Chris Lane, for enthusiastically supporting this event. My special thanks also goes to the convener of the conference, Dr. Ashish Khanna. And I also like to thank the keynote speakers, Professor Vasil Veselov, Professor Sergio Durante Correria, and Anand Bose. Thank you very much. Of course, I'd like to thank all the speakers who will be presenting the papers this afternoon. You will have an opportunity to network amongst each other during the lunch break, as well as we have a reception later on after the event. Tomorrow's event, all the papers will be presented online. And today we don't have a fire drill planned. Just in case the fire alarm goes off, please make your way outside the building. Before we start the talks by this esteemed panel, I'd just like to launch the proceedings officially. So if the distinguished guests don't mind standing up and holding their proceedings, we'll take a few photographs to mark the occasion. It's a bit like Christmas. Great, thank you so much. You may sit down. So, of course, that's yours. So I'm going to ask my colleague here, Richa Sharma. She's going to take over the show. So over to you, Richa.
Thank you, Bal. And thank you, everyone here. Welcome you all to London Metropolitan University. It gives me immense joy and pleasure to be hosting the 4th International Conference on Data Analytics and Management, ICDAM-2023. It's happening for the first time at London Metropolitan University. So I would like to invite the convener of the conference, Dr. Ashish Sharma. Ashish is from Maharaja Agrasen Institute of Technology, New Delhi. I have lived there for a few years. So in India, and he has published around 90 research articles in top Scopus journals conferences, and book chapters. So over to you, Dr. Khan.
Good morning to all the respected delegates on and off the dais. So before moving to the statistics of the conference, I would like to thank and give my warm regards to Professor Chris Lane and Professor Balverde from London Metropolitan University for their continuous support and guidance to make this conference a success. I would also like to thank Dr. Pancham Shukla from Imperial College, London, and from Professor Paul Kowalski from Poland for their valued contribution. I welcome my friends, Professor Sergio from Portugal, who always helped us in key matters of the conference. And he is also one of the keynote speaker today. Thank you. So, and I must take some names who are there at India and supporting us. They are managing everything. The name are Dr. Deepak Gupta, Mr. Moochal Sharma, Dr. Ajay Dureja, Dr. Aman Dureja, and Dr. Jameel Ahmed, who is with us today here also from India. So their hard work made this conference a success. My special thanks to Mr. Aninda Bose, whom we have also invited as keynote speaker, who is also the one of the main architect of this particular conference. I still remember the day at CP in Delhi when me along with Dr. Deepak Gupta were discussing about the need around 4 or 5 years back, around 5 years back, in fact, means we were discussing that data analytics today has become one of the most important part of everything. So we need a venue where we can collect certain research papers. We can have some gatherings of some of the researchers from various parts of the globe where we can meet and can discuss. So Aninda Bose told us that data analytics and management, he stressed on this particular word. And I must say today that that has become a success after the statistics of the conference. You will just note, means statistics are a separate thing, but we all know that data analytics has the inroads everywhere. So thank you very much, sir. So today we all know that the data analytics and management, which is our conference, is running in the 4th year successfully. Today we all understand the importance of data. We're predicting correct information by training the model through the available data set has come a very long way. ChatGPT is the latest tool displaying the power of artificial intelligence and data analytics. We need more platforms like ICDAM, where the huge number of research articles which are coming from multidisciplinary researchers so that they can publish those papers. So without taking the time, I would like to come to the statistics of the key statistics and the achievements of the International Conference on Data Analytics and Management 2023. ICDM 2023 has already been organized in 3 years at Poland. We started in 2020. ICDM 2023 has received around 1,200 research papers, and out of that, only 190 research articles have been accepted with the acceptance ratio of just 16% from around 28 countries. All the selected research articles will be published by the reputed LNNS series, Scopus series of Springer. Top papers of ICDM 2023 will be given the chance to be published in the following SCI and Scopus journals. Some of the journals are Expert System of Wiley with an impact factor of 2.53, Alexandria Journal, Engineering Journal of Elsewhere with an impact factor of 6.6, Computer and Electrical Engineering of Elsewhere with an impact factor of 4.15, IEEE Journal of Biomedical and Health Informatics with an impact factor of 7.0. Some other journals from MDPI are Sensors, Sustainability, Electronics, and Two other Scopus and ESCI journals are Intelligent Decision Technologies and Intelligent Automation and Soft Computing. This fourth version of the conference is getting organized in hybrid mode at London Metropolitan University, along with the support of co-organizing institutes from Portugal, Poland, and India. Some of the names already have been taken by my friend, Professor Bal. So multiple country university participation in co-organizing the conference makes ICDM truly international. With this small technical information about the conference, I welcome you all. I welcome our keynote speakers, Professor Sergio and Aninda Bose, Professor Vessel, our steering committee members, and most importantly, our authors from various parts of the globe who have joined us physically also, and obviously due to the other protocols, traveling and other COVID-related protocols, the online is a new mantra. So they are a lot of authors has joined us online also. Now the conference is on, and this conference is a huge success. So I welcome you all, and you all can share your knowledge, can do the networking, and can take research forward for the purpose of mankind. Thank you so much.
Thank you, Dr. Khanna. I would like to invite our General Chair of the conference, Professor Karim Ozan. Karim is a Senior Professor of Computing and Knowledge Exchange. He's also the Director of Research and Enterprise for the School of Computing and Digital Media. Professor Ozan has published extensively in top journal papers, including on subjects including AI, cybersecurity, big data, computer vision, and speech recognition. Over to you.
Thank you, Richard. So, first of all, good morning and welcome to London Met. I'm going to be very brief. As my role as head of research and knowledge exchange in the School of Computing and Digital Media, first I would like to thank Professor Balverdi and his team for this excellent work to make this conference happen. It is my really great pleasure and honor to stand before you today as we gather here to really mark the opening of this excellent conference. This event serves as a platform for knowledge exchange or for exchanging knowledge, also igniting discussions and fostering and nurturing collaboration that will shape the future of our fields and businesses in particular. Remember, we need really to contribute significantly to our economy through collaboration with our business partners. Throughout the course of this conference, we will delve into a wide array of topics, from cutting-edge technologies and scientific breakthrough to social issues. We will explore, presumably, the frontier of knowledge, challenge conventional thinking, and seek new horizons. However, as one of my colleagues mentioned about 2 minutes ago, this conference is not just about disseminating or dissemination rather of information. It is about creating an environment of collaboration. This is what knowledge exchange is about. Forming lasting connections, building synergies, and also networks. So finally, without any further ado, well, I have one more thing to say. I encourage each one of you to actively participate, to ask questions, to sort of challenge assumptions, and to engage in robust discussion. That's what makes really the conference very successful. So in summing up all this, so share your knowledge, share your experiences, and together let us make this conference a catalyst for a change. Thank you very much.
Thank you, Karim. Now, I would like to take the opportunity to invite our Dean of School of Computing and Digital Media, Chris Lane. He has about 65 academic staff from 3 distinct subject areas, including computing, communications technology and mathematics, and digital media. Over to you, Chris.
Risha, thank you very much. So, yes, I would like to, on behalf of London Metropolitan University's Vice-Chancellor, Professor Lynn Dobbs, and also our PVC for Research, Don McCrail, welcome you to this conference. Special welcome to the conference partners. So Karkonosze University of Applied Sciences at Jelenia Góra in Poland. Sergio. Oh, sorry. Apologies. The Politecnico of Portalegre, which is Sergio, and Bhagwan Parshuram Institute of Technology in Delhi, and also especially to Professor Ashish Khanna from Maharaja Agrasen Institute of Technology. London Met is committed to supporting innovation through international collaboration. And I think as a university, at the heart of arguably the world's most socially diverse and multicultural city, London, I think we place the achievement of social justice at the heart of our goals and our mission. I know personally about the impact and power that data has to transform industry, as Karim has talked about, and society for the better. And I think in part that's because I'm a user of data myself as a manager in a large educational institution with over 20,000 students. But I'm also, as well as being an educational manager, a leader of a disciplinary area that is the home, and this is as Bal has said, to world-leading data analysts, statisticians, and specialists in computer networking. And I note that the conjunction and focus of the conference today and tomorrow is on data analytics and computer networking. So that's very exciting for us. So I think, I'm particularly privileged to be able to be the person who's helping to host this conference, a conference that's so well aligned to London Metropolitan University's mission and interests. Now, I just wanted to say something about the current period that we're in. It's an era of, we'll all agree, unprecedented technological advancement. Data is driving innovation, reshaping industries across the globe, and unlocking unimaginable opportunities. I think we all know that. It almost goes without saying, but we should remind ourselves of what a moment in history we're in. I think we find ourselves in a place where data generation is growing exponentially. With every user interaction, new potential insights are being created. And I think I would say that with a wealth of data comes very significant responsibility to make sure that we harness this power in an ethical way. So I think as data practitioners, we bear this immense responsibility. We need to create transparency, we need to respect privacy, and produce fairness when we are thinking about the guidance that we take over our actions. I think we must address societal challenges like poverty, corruption, the climate crisis, diversity, and our goal, and I think this has already been said by other speakers, is to create a better world for all. And I think the people in this conference are really at the forefront of producing those potential changes. So I think, again, actually, as Karim has said, this conference serves as a platform to build on the latest advancements, to delve into challenges and witness real world impact, because I think what we'll be seeing from the presentations that are taking place throughout the conference, and there are so many amazing papers. I've just been looking through the list in the brochure. We're going to be witnessing real world impact in the work that people have been doing. So over the 2 days we'll be hearing from academics who push boundaries. I think I implore you to engage in the conference sessions. I'll be around and hoping to network with you. And I hope that as a result of that, we'll build new collaborations. And I'd also like to add that I think I'm confident that this conference will present a really important new opportunity for London Metropolitan University's international work. And we're already discussing the potential for signing memorandum of understanding with MAIT. So that's something that's going to be really exciting and important for us. So to the organising committee, sponsors, and all who've made this event possible, I want to thank you. And do take the chance to speak to me during the conference. Good luck on your 2-day journey. I know this is going to be an absolutely fantastic event. And I'll hand back to you, Risha.
Thank you. Thank you. I would now like to invite the conference publication chair, Professor Sergio Duarte Correa. Sergio is head of Electronics and Instrumentation Laboratory, and his research interests include wireless sensor networks, which is my area of interest as well, AI, software computing, signal processing, embedded systems, computer architecture, to name just a few. Professor Correa has published numerous research papers in various journals and conferences. So thank you.
Thank you. So good morning and welcome to the 4th edition of the National Conference of Data Analytics and Management. This year we are at the London Metropolitan University. I would like to thank for the hospitality, for the excellent conditions that we have here, either in terms of architecture, either in terms of the technological means that we have here at our disposal for this hybrid mode conference. I would also like to highlight the support of the partner institutions, namely the Porto Alegre Polytechnic University, where I come from, but also the Carco-Nost University of Applied Science and the Bhagwan Parshumer Institute of Technology in India, but also all the team members that built this 2023 edition spread across the several committees. And I would like to address a special thanks to Dr. Ashish for having invited me to be here today and be part of the great team that organized this conference. I would like to extend the thanks to all the attendees and participants that will be here with us in the next 2 days. I will just end up by mentioning that the several hundreds of submissions spread across dozens of countries to this conference demonstrates the importance of the theme that we will be discussing in these 2 days. And that it shows the intention and the importance that the scientific community gives to this subject, to this field. As such, I think that we can say that the organization of this event is fundamental for the advance of science, and that the proceedings that will rise from this event will be a collection of excellent works for science and will contribute definitely to an advance in this field. Thank you.
Thank you, Professor Correa. Now, I would like to invite our next conference chair, Professor Dr. Abhishek Swarup. Abhishek is head of Department of IT at Okay. So now I would like to invite the conference chair, Dr. Zdzislaw Polkowski. Zdzislaw is professor at the Carco-Nost University of Applied Sciences in Jelenia Góra, Poland. He was formerly Dean of the Technical Sciences Faculty at UZZM in Lubin. Dr. Polkowski has published more than 120 papers in journals, 25 papers in conferences, and has co-authored 5 books. So he will be joining online.
Yes.
So
hello. Yes.
can you?
Okay.
Yes, we can hear you.
Yes, thank you very much. Ladies and gentlemen, we are deeply honored that for the second time we can take part in such an extraordinary and important scientific event as Fourth International Conference on Data Analytics and Management. We are very happy to be here, and we know that this is not only the matter of exchanging scientific achievements and ideas, but also extraordinary occasion to build intercultural bridges, to share opinions and inspiring views on our realities. So I hope that everyone will have a chance to contribute to the importance of this scientific event. What's more important, I'm very happy that together with Professor Polkowski that has just been presented, and me, the Dean of the Faculty of Humanities and Social Sciences at the Karkonosze University of Applied Sciences, we've got also a young participant, our third-year students of English Philology, Hubert. So it shows that it is essential to involve young people in such events and such conferences. Thank you once again for the occasion to be with you, to share the achievements, the scientific achievements, the opinions, and I hope that all the participants will benefit a lot from this conference. Thank you very much once again. Wish you a lot of inspiring dialogues, a lot of interesting outcomes for your institutions and also for you personally. Thank you very much and good luck.
Thank you so much. Thank you for joining us online. It would have been great to have you here, but thanks to technology, we can still hear you and see you. Thank you very much. Now I would like to invite our next conference chair, Professor Dr. Abhishek Swarup. Abhishek is Head of Department of IT at Bhagwan Parashuram Institute of Technology. Professor Swarup has published many papers in journals and conferences, and he'll be joining us online.
Thank you. So, am I audible? Hello.
Hello, we can hear you. And
okay, thank you. So, on behalf of ICDAM-2023 and Bhagwan Parashuram Institute of Technology, New Delhi, I wish my sincere thanks to the organizers and all the attendees. Actually, I would like to briefly introduce Bhagwan Parashuram Institute of Technology. We are an institute providing engineering and management education in the New Delhi, and we are affiliated to Guru Gobind Singh Indraprasth University. All our engineering programs are accredited by NBA. As far as this conference is concerned, the success itself is evident from the number of submissions and a very low acceptance rate of 16%, which shows the quality of papers which have been accepted. And this is because of the hard work of the entire organizing team, as well as the importance of the theme of the conference, because data is the new oil and the importance of data cannot be overemphasized. However, if we do not properly manage data and analyze data to get meaningful information, this data will be of no use. That's why the topic and the theme of the conference is very much relevant. And I hope the researchers from the various parts of the world will interact and will lead to the new frontiers and will bring new laurels to the area of this data analytics and management. And I wish all the best to all the participants. Thank you.
thank you, Professor Swarup. It was really nice to hear from you. And with this, we would like to move ahead with our, yes, okay. And we would like to move ahead with our vote of thanks by Dr. Deepak Gupta, who would be joining us online as well. And Dr. Deepak Gupta. Dr. Deepak Gupta, can you hear me? I can see you are online.
Yes, you are audible. And am I audible?
Yes, you are audible.
Yeah. Okay. Thank you so much. I am really happy today to see all the amazing people on the stage. And this time it is a fourth version of ICDM. And for the first time, we are doing it in hybrid mode, in physical mode as well. So I am really happy. And good morning, good afternoon, and good evening to all the participants of ICDM 2023 around the globe. We have 190 paper presentations in the coming 2 days in online and offline mode. I deem it a great honor and privilege to propose the vote of thanks. First and foremost, I would like to express my heartfelt thanks to Professor Karim and Professor Bal from London Metropolitan University, Professor Chris Lane, Dean of School of Computing and Digital Media, LMU, Professor Magdalena from Cargonews University of Applied Sciences, Poland, Professor Sergio from Polytechnic University, Portugal, Professor Abhishek Sarup from Bhagwan Parshuram Institute of Technology, India, and Mr. Aninda Bose from Springer Nature, London. I would like to thank them for their valuable time and presence in this inaugural ceremony of ICDM, fourth version of ICDM 2023. I am also grateful to our general chairs, Professor Genesus from Polish Academy of Sciences and Professor Alipi from Polytechnic University of Milan, who are not present with us currently, but they have supported us during the organization of this international conference. I would also like to give my sincere thanks to Honorable Pro Vice Chancellor, Professor Don McRae, London Metropolitan University, and Honorable Rector, Professor Violeta from Cargonews University of Applied Sciences, Poland, for their leadership, a constant support of motivation, and creating an ecosystem for the smoother conduction of the fourth International Conference on Data Analytics and Management. It is my pleasure to thank the keynote speakers of ICDM 2023, Professor Vasil from London Metropolitan University, UK, Professor Sergio from Polytechnic University, Portugal, Mr. Aninda Bose, Senior Editor, Springer, London, Professor Alfredo, Idea Lab Director, University of Calabria, Italy. We are grateful to them for accepting the invitation and to take part in ICDM 2023 in physical and online mode, and will share their expertise and knowledge on the topic with the participants of this conference. Next, my sincere thanks goes to all the faculties and staff of the organizing universities, that is London Metropolitan University, the Cargonews University of Applied Sciences, Poland, Polytechnic University, Portugal, and Bhagwan Parshuram Institute of Technology, India. Without their support, the conference would not be possible. At last, I would like to thank our sponsors, student volunteers, reviewers, special session organizers, participants, keynote speakers, and publication partner for their constant support in organizing the conference in hybrid mode. Now, I am happy to announce that the conference is a grand success. It is an honor for me to thank all the participants and the attendees of ICDM 2023. Thank you so much.
Thank you, Dr. Deepak Gupta. It was really nice to hear from you from so far away. And with this, we would move on to the keynote speeches. And our very first keynote is by our very own Professor Vasil Vasilev. And as tradition would have it, there is no Q&A session after the keynote, though you will have an opportunity to discuss it with the speaker in the break between lunch between 1 and 2. And I would like our panel members to please take seats in the very front row. Thank you.
Thank you.
Thank you so much.
Morning. Can you hear me? Yep. Good morning here in London and good afternoon to the audience in India. My name is Vasil. I'm professor at AI and Intelligence Systems in London Metropolitan University and director of the Cybersecurity Research Center of the university. I will be talking about data platforms and specifically the problems of integration and hybridization of data processing, which is critical in the case of data management. My talk, which is planned to be about 50 minutes, will cover the following things. First, very briefly, I will discuss the evolution of computing from the desktop to the cloud and beyond, in order to position ourselves within this trend and to understand the context of the major issue in focus, namely the data platforms. Next, I will present the concept of data platform on the private cloud we have implemented here at the London Metropolitan University within the Cybersecurity Research Center, and which we also replicated to our partners in the University of Sofia in Bulgaria, where similar platforms been established. Then I will concentrate on the major issues which need to be addressed in order to build such a platform. The data, the metadata, the technologies, the tools which need to be chosen carefully and integrated seamlessly so that the platform can function. And of course, in the conclusion, I will discuss briefly our view of the future. So, the evolution of computing. Computing is a relatively young engineering discipline, but it went through different stages, which are linked to the progress in technology. So it started with the traditional development where on top of the hardware infrastructure, we have operating system executing applications. That's the early stage of the computing, which was dominating up to the age of the internet and networking, roughly during the 60s and 70s. Around the 80s, the concept was upgraded, started being upgraded with the new idea, the idea of virtualization. This idea means that we are starting emulating different on a platform which is hosting them. An early example of such an emulation was the switch from Apple processors to Intel processors done by Apple, which allowed to emulate the architecture of different system on different hardware in order to leverage from the more advanced features of the new hardware. Of course, this process didn't finish and it continued for maybe around 20 years, developing more and more elaborated concepts such as hypervisors, which allow you to manage the different virtual machines. And as it is at the moment, this builds a stack. At the bottom of the stack is the hardware, then we have the operating system, then we have the hypervisor, which manages the virtual machines. And each of these virtual machines runs its own version of operating system, which creates an environment suitable for the needs of the users to work. This created an opportunity to do things which were not possible before. One example is our university. I remember the time when we were running all our educational services and we were working within the network of the university. At a certain point, we outsourced this to a foreign company, which implemented full virtualization of our network. and allowed us to forget about the maintenance of this environment we are actually running, and to run all our services, both educational and management services, on the virtual machines, which are managed by external entity. That's how we migrated our email, our information services, and many other services which are supporting the business process of the university. At certain point, the concept of virtualization was revised, and the computer scientists devised a better solution. So instead of using a virtual machine, which emulates the hardware, why not to use a software engine which creates the environment without trying to emulate the hardware? That's how the containers were born. And the containers are extremely important because they're in the cornerstone of the contemporary technology for computing on the cloud. So the containers make the cloud really widespread. So this new architecture, where the containers run within the virtual machines or within the operating system, on the cloud or on the laptop, create an extreme flexibility in the environment we are using to develop and the environment we are using to execute the services we develop. So the data platforms is a new software environment which was created to support the needs for processing of big data, for processing of data which normally cannot be processed on a single physical device. That's became possible because of this needs to meet the requirements of big data over the internet. The data platforms need to address several issues. First, they need to provide sufficient computational power to support computationally hungry data processing linked to the big data. Secondly, the platforms need to provide sufficient space for accommodating this data, which exceeds the capacity of a single computational device. Next, the large variety of data formats, transportation protocols, processing modes requires hybridization, integration of a number of different components which are difficult to see on one single device. Next, the full life cycle of the data from the moment the data is being generated at the source up to the moment the data is being consumed in a certain suitable for the end user's format. It's a long journey which goes from place to place, through process to process, and cannot be done by a single device. And finally, something which is both good and bad: centralization. Centralization allows the development, deployment, operation, and maintenance to be done from a single point, from a single place, which is very convenient, which is also a bit of a problem because it concentrates extreme power in one single place. And that's what happens with the cloud technologies. The cloud technologies are currently made available from the big vendors, from the big service providers, to serve the needs of various customers. And at the same time, they empower the service providers, because the service providers now are having hundreds, thousands, and even million customers which are paying for these services. So this concept leads to further centralization of resources and capacities, which leads to the race of the big companies such as Amazon, Microsoft, Oracle, IBM, and so on and so forth. But this works, and the best proof that this really works, and it works well, is the not so long ago finished pandemics. I remember the time when our university was closed, 21st of March, 2020. In one day, we closed the university and on Friday, and on Monday, we continue working business as usual. Why? Because we were able to use the cloud. So everything was migrated to the cloud. Of course, the preparation was done before, but the migration took one day. And the second case, I remember 31st of April this year, I was checking my email on Google and everything was fine. And the next day, on the 1st of March, I looked for my email on Google and Google didn't allow me to access. And then I remembered that we are in a process of migration of these services, looked at my emails and found out that we are now on Microsoft. I went to Microsoft. It took me a few minutes, of course, to adjust to the new environment, but it was all there. So it took just one day. In one day, we switched from one environment to another environment, another cloud provider, but it worked. So this is a great proof that this tendency of centralization, when it's done properly, when it's done by the authorities who can do it properly, works. So this is how we are coming to the idea of cloud-based data platform which centralizes most of the resources needed to support the development, the deployment, operation, and maintenance of all these facilities and services needed for processing of big data on the virtual single point called cloud. So this picture illustrates roughly what do we mean by data platform on the private cloud. That's exactly what we've been trying to implement here at London Met, and to a large extent, we can say that we have managed to implement it. So within the cloud, you can see the cloud infrastructure. It involves front end, it involves middleware, it involves backend, number of different machines, number of virtual machines, number of different services operating within different contexts, containers, machines, operating systems, which are dealing with different phases of data processing. Some of these are just data storages. In our data platform, we use 4 data storages. We use one conventional SQL database. We use one NoSQL database. We use one graph database, and we use one big distributed system for processing big data based on Apache Hadoop. So 4 different data storages to accommodate all different types of data we have. We have several different protocols we are supporting to transfer data from outside world to the cloud for processing, both in a synchronous and asynchronous mode, both in terms of a flow of constantly arriving messages and large batches of upload of information using different technical protocols. This cloud platform is being developed so that it can accommodate both small but fast-growing data in real time coming from sensors and other sources of information, asynchronous sources of information, such as Twitter, for example, and also to accommodate data coming from large repositories, such as, for example, databases, so that this data can be processed on the cloud according to the needs and the tasks specified. On the other hand, we have the developers who are able to work on the cloud from the convenience of their laptops and desktops, and the end users who are able to consume all these services on the laptop or the desktop or on even the mobile phone, depending on the needs. So what the data space brings to this picture, if the data platform on the cloud is total centralization, the data space is just the opposite, total decentralization. The data space concept is a computational environment for processing large data. It's being developed mainly in Europe, initiated at Fraunhofer University in Germany. That's related to the German tradition in manufacturing and the needs for communicating between multiple smaller organizations which are dealing with different stages of developing the products and the need for exchanging information amongst them in order to guarantee the supply chain uninterruptible. So that's not an accident that the idea came from Germany. This idea addresses the need for exchanging of data between large sources of information over the internet, first. Second, doesn't require that the data needs to be stored in one place. It can stay where it's being generated. Third, it doesn't require ownership of any kind. The operation of the data space may provide services to each of the parties without these parties have access to the data and without owning this data. So, for example, you can imagine that you may need to use data about individuals, but according to the GDPR, you're not allowed to reveal the identity of these individuals, and you don't need to know who these individuals are. You can use just the IDs, and the database which stores the individual details, the personal details, is not owned by you. You don't have this data. You can still do the analysis which is needed in order to investigate the statistical distribution, for example. Further, the data space retains the ownership, but shares the services across the participants in the space according to their rights. Some of the participants may be just consumers of the data. Some of the participants may be data providers. Some of the participants may be both consumers and providers. And the data spaces can have data platforms as members, which means that the data platforms can both leverage from the consumption of data from the space and can supply data services to the data space for common use. This concept's been further developed by the adopted widely across European Union and further developed by the International Data Space Association, which even standardized the data platform requirements for being part of the data space. That's an example of the old concept of service-oriented architecture, which actually data spaces rely on. In the data service architecture, in the service-oriented architecture, you have a number of different services appearing in different modes. Some of them, as I said, providers, some of them consumers, some of them both consumers and providers. And the network grows as it's necessary based on the supply of data and processing services there. Just as an example is the urban mobility data space we are currently working on developing together with our partners in Sofia, and which we intend to extend in the direction of healthcare here in London. So let's say we have the City Mobility Center, which deals with the transport, like the transport for London here in London, and like the City Mobility Center in Sofia. Let's say we have the Environment Control Agency, which deals with the state of the air pollution in the city. And we have the Urban Planning Department, which resides somewhere in the mayor's office. So these three organizations are both providers and consumers, and they have certain rights with respect to the data which exists within the space. For example, the City Mobility Center is mainly providing data to the Environment Control Agency so that we can relate the traffic to the pollution within the city. The operations which are supported are distributed among the two organizations, and the rights to access the data and to use the corresponding organizations are also based on the contract between this organization. The third organization, Urban Planning Department, is usually related entirely to the Environment Control Agency, so it has different rights with respect to the data and different rights with respect to the operations which can be executed. By sharing data and services within this space, these three organizations can leverage from what they can use as a common resource within the space. So the data platform support for data spaces, which is one of the focuses of the data platform development, is with respect to the consumption and provision of data services. So from the point of view of the consumption, we need on the data platform to be able to identify the services, to address them properly in order to communicate with them. Secondly, we need to be able to identify the consumers which we are going to supply with information through authentication and other mechanisms for security. Next, we need to be able to request service from the space and to request consumption of service for ourselves from the space. This is with regard to the service consumption. With regard to the service provision, we need to be able to register our providers and consumers through the mechanisms of identity management on the cloud. We need to be able to assign responsibilities with respect to the different services which are executed by the different parties, and so on and so forth. So there are a number of technical requirements which exceed the standard requirements to data spaces, which is fully to the data platform, which is fully centralized by its nature, when the data platform becomes member of the data space. As I mentioned, there is a European organization which certifies the data platforms with respect to their possible participation in data spaces. This is Gaia-X initiative of the International Data Space Association, which is also based in Germany, and which is which currently involves most of the EU countries. Now I'm going to switch to what we have, to our platform, to the data platform on the Cybersecurity Center, which we replicated in Sofia. It is cloud-based. We run our cloud services on the 7th floor of the tower building up there. And it contains both virtualization and containerization, as well as orchestration of the services, so that we can combine the services and orchestrate them in a workflows for executing various processes. It is based on the most popular container management system, Kubernetes, and we are running Docker containers within the server. We have installed, as I mentioned, 4 different databases, all of them based on the public domain software, because we are an educational institution. But all this public domain software is well recommended, and in many cases, it's actually the core of the industrial services. For example, Hadoop, we are using, which comes from Apache Software Foundation, is actually the prototype of Cloudera Hadoop, which is the flagship Hadoop version in industry. MongoDB, we are using the community edition, is the same MongoDB which is available to the industry as well, with certain limitations, and so on and so forth. So on top of these resources, we can run our applications, be they in Python, Java, R, or any other languages. And in order to develop them, we are using Proxmosis, a remote service, which allows us to work from anywhere. It's funny because when during the pandemics, when the university was shut down and the services were down, and we had to move to another place to work in Sofia, we found in our partners such an opportunity. Later on, here in London, in a company, we found an opportunity. And using this remote mechanism, we were able to continue working remotely. And the interesting thing is that one of the first flagship projects we developed as a prototype implementation was entirely developed from a distance, but it was running. So we developed it here in London, but it was running in Sofia. So we were generating the data here in London. We were sending it to Sofia to analyze it, where we install remotely the services needed to process the data, because our university was closed and the server was down. So this worked. After this first successful implementation of the concept, we and because we were hosted by our partners in Sofia, We replicated this concept in Sofia. Not only this, but we started working on a project for them, which was funded partially by the Bulgarian government, partially by the European Union under Horizon 2020. It was a project for controlling the environment pollution in Sofia, which was one of the most polluted cities in Europe. So remotely from London, our team, the same team which worked on the first pilot project I will talk in a while, developed another project which is still up and running in Sofia even now, and which shows the environment pollution in the city. Then we saw that actually this concept not only works, but we can utilize it. We can develop it further. So we migrated the system back to London. So we have our own system here in London, which shows the distribution, shows the environment pollution amongst 130 different stations in London. Of course, there are other systems. There are systems which are probably developed better, but we implemented it with a bunch of students, and we are running it on our own server, and we are constantly adding services to it, which are not available. And we constantly implement ideas which are not available from the industrial service. So this process is ongoing. We are continuing, and we are hoping the next year we will be able to step on the track of linking the environment services we have implemented to certain data analytics related to healthcare, in order to see how the pollution in certain area affects the potential respiratory disease in this area by analyzing the prescriptions in this area. So the first pilot which proves the viability of this concept was purely cybersecurity project. It was about real-time analytics for a detection of potential intrusions. So we implemented the staging environment. We started the project before the pandemics. And before the pandemics, we were working with a company which hosts certain infrastructures for industrial partners, and they wanted us to do the analytics for them. But once the pandemics came and the lockdown struck, we had to abandon the idea of using the data from the company. So we created our own data. How we implemented a model staged environment. We were running a number of different machines and certain viruses on them, Trojan horses and all kind of nasty things, in order to generate traffic. We were capturing this traffic and we were sending it to Sofia, where on the cloud we were analyzing this. So from this staging environment over the internet, we were able to transmit the data in real time and analyze it by using first light correlation mechanisms. So we were correlating the event logs generated by the various levels of this technological stack with the Wireshark, which was captured by the network analyzers monitoring the different hotspots. So by correlating these two streams of data, we were able to capture additional a malware which was not captured by the separate devices. So once we did this correlation, then we gathered the data so that we can conduct more a more serious, more deep analysis, more forensic analysis. This table summarizes the result of the forensic analysis of the network packets using the SVM method. We tried several different methods and we found out that for the purpose of this type of analysis, SVM works very well. As you can see, up to 90% accuracy was absolutely sufficient. We also experimented with deep learning. We were running CNN to do more thorough deep learning based analysis of the data, but the data didn't show more information which is worth doing it. So we ended up with a conclusion that SVM is the best for the purpose. So that's the result of the use of CNN for the same purposes. Of course, better results, higher precision of results, but not so much necessary for the task. So then we migrated, as I said, to the second project. That's the environment pollution in Sofia, with all the stations, the data coming from different stations. The last time I visited, and as you can see from the slide, it was okay. When was it? 2 days ago? Sometime 22nd of June. That's the last reading I have here. So it shows the level of CO, humidity, NO2, NO3, and so on and so forth in the different spots. That's the picture of the mirror project we implemented here in London. Obviously, in London, there are more stations, the bigger city, and more information. The same concept implemented in a completely different place, in a completely different environment for the same purpose. But we didn't stop there. We continue trying to do more analysis, to incorporate more technology. So that's part of the logical model of the ontology of the city area, which would allow us to identify actually the polluter. And it's funny because when we saw the first picture of Sofia, and because I'm coming from there, and I saw that the most polluted area is the northwestern part of the city, and my idea immediately was, there is a power station there, must be the power station. And I had this idea in my head until they told me, oh, but the power station's not been working for 3 years. So it's not the power station. So then I said, okay, I'm wrong in my assessment. Can I check what else is there? Behind is the airport. So that was the source of the pollution. If we had a model at that time, this conclusion could have been generated by the system. So this is one of the reasons we continue working in this direction. We mix the semantic model of the area with the numerical readings from the sensors in order to analyze the potential polluters. Further, we came to the idea, okay, we can see the environment pollution conditions outside. Why don't we go inside? Of course, it makes sense if we're going into the shard, but for small buildings, it doesn't make big difference. But actually, we have a currently project with an industrial company which runs a number of blocks of flats containing 700 apartments. So for 700 apartments, they want to have 3 sensors in each of the apartments, and to see a comprehensive picture of the environment within these apartments, because they are managing them. So this is how we move to the next task. Let's go in. And this shows the first successful integration of the building reconstruction with the flat 2D representation of the area. So this building reconstruction you can see here has been reconstructed by us based on the floor plan. This is kindergarten in Sofia. And we managed to create 3D image, which we integrated with the 2D flat map of the city area in order to be able to go in and to fine tune which floor is precisely the polluter. We continue working in this direction as well. So for example, now we are trying to integrate also the movement of the air inside the building, so that as a result of the analysis, we can recommend to open the window, or the other way around, to close the window to stop the pollution coming from outside. So these are the things which we are continuing working on now. That's the mirror here in London. That's actually the sensor located on the 7th floor of our tower over there, which Dion on the back bench here implemented from scratch in order to capture the level of pollution inside the university building. So this is a real picture from a real time. Of course, this is from last year, the picture when we captured the level of pollution inside. And why we are doing it, because how we are doing it by correlating the outdoor and indoor measurements. So you can see very close resemblance of what's going on outside and what's going inside. But there are also peaks which are not present. And we were thinking, okay, the yellow is inside. Why there is a peak? Because they were building works. And when they are building works, you know that they spread more dust and the air quality goes down. So this peak is not caused by the external factors, it's caused by internal factors. So this picture shows also the power of the analytics we perform. These three great projects prove the concept and prove that it's possible even within academic environment using free tools to implement relatively complex solutions. We are continuing working, we are very enthusiastic, and we are hoping next year we will be able to bring one more element. We will bring the prescriptions of medications so that we can investigate why in this area there are prescriptions for medications linked to respiratory disease because of the pollution in this area. That's something we can provide as information for the decision makers. We are not going to solve the problems of the city, of course, and we are not looking for this, but with what we are doing, we are trying to help the decision makers make the better decisions. Now, I'm briefly going through the choices you need to make in order to assemble such an architecture and to be able to utilize its power for the purpose. So there are a number of different alternatives we need to consider. Why? Because it is extremely complex. It's extremely complex from the point of view of the data, from the point of view of the scales of data, the diversity of formats, the variety of methods you need to use to process the data. One method may work well with one piece of data, but not with another piece of data. One and the same piece of data may work well with this method over a certain period, but not over a longer period, and so on and so forth. So there are a number of choices which needs to be made, and they need to be made in such a way that everything fits within multi-criteria optimization task. So data, are they single samples we are getting, or files of data, or separate messages which are constantly arriving, or whole collections coming from an external repository or online stream? That's one thing we need very carefully to examine and in order to make the right choice. What's the information which we have for this data, the metadata? Is it in terms of attributes only, or it's also interrelation, so that we know what kind of data model we need to use in order to store this information and to use it later on? Is it object-oriented, purely relational, semantic model, and so on and so forth? What kind of technologies are there for processing this type of data? Is it and where this processing needs to happen? Before we transfer the data or after we collect the data? Before we store the data or after we put it in the data store? What kind of preparation we need to do? Do we need to clean the data, or it's already clean enough? Do we need to label the data, or we can process it as it is? And so on and so forth. Number of different choices which affect what we are putting in the platform. And we are coming to probably to the last choice, which software to use, which tools to use. This summarizes what we are using. So virtual machine, hypervisor, container manager, engine for executing applications, servers, applications, services, microservices. These are the different levels of the technology stack needed to assemble this whole picture, to integrate it into one homogeneous environment which support the large diversity. I'm not going to go through the details of the choices, the alternatives. If you're interested, you can have a look, but there is a choice for everything. And there is a free choice for everything. And you can put it yourself, of course, in a team, because it's a teamwork. As a conclusion of this, what is the big advantage of utilizing cloud-based data platform on the private cloud from containerization point of view? You can modularize your applications. You can efficiently use the memory. You can port the applications from container to container, from platform to platform. You can even automatically generate the configuration for running these applications. And finally, It's all traceable. You can organize the testing process so that you can very carefully monitor it and trace it. From orchestration point of view, this containerized application is not working alone. It's part of a pipeline, of a workflow, which may involve number of different containers, number of different applications. So you have to develop a model of this business process. And the good thing about doing it on the cloud, the way we are doing it, you can also audit the use of the data, the use of the services, so that if you're providing commercial opportunity, you can bill this to the end customers. And of course, in the end, all this can be automated. The software which is available allows this to be automated. It's a long shot, it's a work, but it can be done. And final, where to go from here? There are a number of different directions. First, as I mentioned, we are pursuing cross-domain integration. We want to link the environment with the transport and with the healthcare. That's very important because this will reveal unexpected dependencies, which will make the decision makers think. Second, we can also combine the real time with the archived data over the last 5 years, over the 10 years, and investigate the trends. Next, we can bring the logical analysis. What is the reason? Who are the culprits? What can be done in order to improve the situation? And of course, we can also pursue some additional flexibility by incorporating optimization and adaptation methods based on reinforcement learning, based on contemporary optimization, so that we can do the things better. If you want to see our path, this is the number of publications since we started. We actually started with the public cloud, and our first project, which we reported to a conference in India 2020, was based on the work on a public cloud. But since that moment, we've been working on the private cloud, and all these publications are related to the experience on the private cloud. Any questions?
Thank you, Nasser. All the viewers will get all the audience will get the opportunity to ask questions in the lunch break period from 1 o'clock to 2 o'clock. So we'll move on to our next keynote presenter. Thank you, Vasil. It was a brilliant keynote presentation. Thank you, Vasil, for a very informative keynote speech. I'm sure we all learned a lot from it. And you showed us how data and containers, etc., how they're used and how various applications can be installed in various ways. And I would like to take this opportunity to ask Sir Anindya Bose to give the certificate to Dr. Vasil Vasilov for his immense contribution to the keynote speech today. So our next keynote speaker is Professor Sergio Duarte Correa. Sergio received his diploma in electrical and computer engineering from the University of Coimbra, Portugal, an MSc degree in Industrial Control and Maintenance Systems from Beira Interior University, Portugal, and a PhD in Electrical and Computer Engineering from the University of Coimbra. Currently, he is an associate professor at the Polytechnic Institute of Porto Alegre, Portugal. He's a researcher at 2 institutions, and they are Lusafona University of Humanities and Technology in Lisbon, Portugal, and Polytechnic Institute of Porto Alegre, Portugal. He has worked with several private companies for more than 20 years. His current research interests are wireless sensor networks, AI, software computing, signal processing, embedded systems, and computer architecture. Over to you, Sergio.
Thank you very much for this very complete introduction. I think I can. This. So I will be presenting my thoughts about efficient inference of neural networks through quantization, and I will try to show you a practical approach. Well, I come from Porto Alegre. Porto Alegre is located vertically in half of the country and then near the border with Spain. This is our campus. I also manage the Laboratory of Electronics and Instrumentation of my university. We are a team of members. We work, we do applied research and work with some companies on some more engineering implementations, such as product development, electronics, and automation. Now, I will go through, this is our to-do list that we will try to accomplish in 50 minutes. I will break down the title of my presentation. So why efficient inference of neural network? Why do we want to do it efficiently? What is this through quantization? What is to quantize? And let's try to break down this with a practical approach that will be on fault detection, okay, through acceleration measurements. So why to perform the deployment, the inference, the deployment of a neural network efficiently? Well, if we go through a little history, when we talk about artificial intelligence, I like to put here in the timeline 3 landmarks. The first one was the proposal of the perceptron, the artificial neuron, that the mathematical model that mimics the behavior of our brain. Notice that it was in 1943, almost 80 years ago, that it was first proposed. It was then needed about 30 years with the proposal of the backpropagation algorithm, so that we started to do something with it. Because before it was the networks, that is, what would be the parameters, the weights of a neural network that we should put on this mathematical model. And then my last landmark is the use of GPUs to train the neural network, mostly. Because what this landmark allows is to create larger and larger networks. GPUs, well, somebody had the idea of, okay, what do we do with GPU? GPU is a graphical processing unit. So we do math for graphical processing. What is the math that we do with graphical processing? It's matrices arithmetics. And that's exactly what we do with neural networks. We want to sum, add, and accumulate math based on matrices that represent our neural network. I must add two more small landmarks. Alan Turing was, as far as we know, one of the first persons that asked the question, what if machines could think? And I will put here another annotation that is ImageNet. Basically, what happened here is at that time, we were thinking, where should we go from here? Should we improve our algorithms? Should we have better algorithms? Or should we have better data? What should we do to improve the efficiency and the accuracy of our models? And what happened was that Fei Fei Li in Stanford University, she decided to create what is called today ImageNet. It's a huge database from images that were initially annotated manually, 40 million images manually annotated into 1,000 different classes. And let's go from here with a contest to see what is the best accuracy that we can get solving this problem. Notice that this is not trivial, because if we have 1,000 classes, it means that the last layer of our neural network will have 1,000 neurons. So it will be a huge network. And what we see is that in the first year of the contest, we got the winning neural network structure had a top 5 error rate of 28%. This means that 1/3 of the classifications that we were doing were not on the top 5 choices. Okay, so when we do a classification problem, we obtain the probability of that image being to a certain class. And what happened was that 1/3 of the times, the correct answer was not on the top 5 classes with higher probabilities. 2 years later, we had AlexNet with half the top rate error, half. And what was established here with AlexNet, that it was a huge neural network trained in a GPU. 8 layers, 5,000 perceptrons. We continue, and I will stop here with ResNet. ResNet was the first one to go lower, a target that we have here of about 5%. That is, if it would be a person to do the classification, we would count to about 5% of the top 5 error. And ResNet got lower than that. ResNet has 23 million parameters to be trained. And it just gets worse, because from now we have bigger and bigger and bigger networks, more layers, more perceptions, more parameters to train. As an example, NVIDIA neural network for natural language processing, we have 8.3 billion parameters to train. We are talking about a neural network that has 33 gigabytes to be stored. So where we are, we have neural networks that are getting bigger. Well, my bigger conceptualization here is the number of parameters that I have to train, the number of parameters that I have to store. So this means that the energy consumption, not only for inference and for training, starts to matter. We don't train a neural network by clicking on the run button and then drink a coffee and it's trained. No, we have to put the we have to push the run button, and we have to go out for some days and then come back. It's this that we are talking about. The storage necessity is getting bigger and bigger, and consequently the inference of the network will rely on a lot of floating point operation per second. So we have to start thinking of latency, silicon area, the cost, the computer architecture complexity that we need to perform these computations. So what is this to quantized? If we have millions of parameters, if we would reduce, we don't think a lot of this, but when we train a neural network, whatever we are using, Python, we are using MATLAB, whatever the language we use, our calculations are being done with 32-bit floating points. It's the standard. We don't even think about it. We just press run. But do we need to do it with 32-bit floating points? No, we don't. So why don't we reduce the precision of the weights, the BS, that is what we are training, but also the activation, that is the sum and accumulation that we are using between the layers. If we do a simple math here, instead of using 32-bit floating points, if I would use 16 bits for the representation, I have half the memory storage. I have half everything, with the advantage that if we put everything to integer of operations instead of using floating points, the computer architecture that will perform the math is always also simpler. It's simpler to have an integer operation rather than a floating point operation. So I said 16 bits, why not 8? Why not 4 or 2? If we would reduce to 8 bits, we are using 25% of the space. So 4 bits, we are using 12% of the space for storage. So this is what we want to do. We want to reduce the number of bits that we use to represent our parameters. We will act on those consequences that I was talking earlier, because if I do integer operations instead of floating point operations, I will have lower latency. I will do it quicker. My computer architecture will be simpler. Silicon area and cost will be lower. Energy consumption will be lower, etc. But not only that, but also we can think of other contexts of application of our neural networks. Because if we want, for instance, something like a wearable, and my example, my practical approach will be on fall detection. Fall detection is done by acquiring acceleration measures on the body. And then we have to identify a pattern that is a person to be falling. If I have to deploy my neural network in some server, what will happen is that I have to acquire acceleration measures. I have to send them to a sender. I have a communication channel here. I have to process the information and trigger something from here. We will have latency of transmitting the acceleration signals. We will have privacy issues. We will have energy consumption of transmitting huge amount of data. So if we could deploy our neural network in the wearable, so in a low complexity and low energy processor, we would gain a lot with it. But not only with wearables. If I want to deploy some neural network on my phone, instead of having to upload some information, I would gain with it, once again, for the same reasons. But I need to find a way to put it efficiently in my mobile. So the advantages are huge. The applications of these techniques are from the Internet of Things, healthcare with wearables, self-driving cars, etc. We can find application for this wherever we use artificial neural networks. We will gain on doing this quantization. Now, quantization is not a new concept. We have been using it for many years in the signal processing community. Analog digital converter performs quantization. We sample an old and value and we quantify it. Modulation uses quantization. So this is not the math that is here behind. The concept that is here is not new. We just have to apply it now to artificial neural networks. We can do it with symmetric and non-symmetric quantization, wherever we have our interval values centered in 0 or not. We can do linear or non-linear quantization, wherever we distribute equally in our interval, our slots that we are quantizing. The example that I will show you will be extremely simple. Symmetric linear quantization for the fall detection problem. So what do we do? What is the math behind this to quantize? So what we want to do is, if we imagine we have 8 bits, 8 bits means that I have 255 slots from 56 from 0 to 255 slots. Now, how should I distribute the values that I have among the weights into this 256 slots? This is what I want to do with quantization. Now, when we go until 8 bits, so 32-bit values that are trained as 32-bit values, we could do it during training. I'm simplifying here. We call this post-training quantization. That is, we train our neural network, as we are not talking about to quantize it. We train it normally with the 32 bits, with our Python, MATLAB, whatever software we are using. And then after that, we are going to quantize the neural network. So we look to our weights, what we want to quantize. They will have some interval, let's say from -6.3 to 5.4 would be the interval of the values that I want to quantize. And I would say that if we want to go until 8 bits, and 8 bits would be 25% of storage, round it anyway. Round it whatever you want to the nearest integer. Just round the values, it will work. Just do that. 8 bits. Just round it to the nearest integer. Your neural network will work with almost the same accuracy had you wouldn't be performing this quantization. And you have 25% of your storage space. And you are using from now integer operations instead of using some processor with some floating point unit. So 16 bits, even an 8 bits processor will do the job with this integer math. If we want to go lower than 8 bits, we need some novel techniques to do this rounding procedure. We can easily go to 4 bits if we do the rounding more carefully. But now we don't just round to the nearest integer. We round it more carefully. Basically, we will have here 2 sources of errors. We will have what we call a clipping error. That is, if we treat the extreme values as outliers and we don't stretch our interval to all the values because the extremes will be outlier. I will show you some histograms. What we will see is that the weighted values will be usually centered in 0. So the extremes can be treated as outliers, although it is controversial because we have some opinions in the scientific community that the outliers plays a crucial role on the neural network. So basically, if I have to stretch all the interval, my rounding error will be larger because the spacing that I'm giving to the values will be larger. If I don't consider the outliers, I have a higher clipping error due to the extremes of the interval, but I will have a lower rounding error. So basically, the error that I will obtain to quantize and then to get back my values will be the sum of these 2 errors that I'm having on this rounding procedure. So how, this is the problem that we want to address, how should we round a set of parameters to be stored with a reduced number of bits for the representation? And obviously, we want to minimize this quantization error that we'll be considering here as we quantize, we dequantize to get our values back, and what is the error that I have introduced in my model. But notice that when we train neural networks, we train our neural networks to be susceptible to noise. Imagine a computer vision problem. We train a neural network to recognize whatever, cats. If the cat is in different position, we will continue considering that it's a cat. If the image has more light or less light, we will continue to recognize the cat. If my image has more or less resolution, I will continue to recognize my cat. Just the same image with different characteristics. So it is normal that if I slightly change the weight of the network will continue to work, because it's empirical. If I can slightly change my input image, I should also be able to slightly change the values that I have into my weights. So empirically, this is supposed to work. Obviously, if I want to go to representations with lower bits, notice that 4 bits, I'm representing all my weights with very, very few values. We can go to 2 bits. It's possible. In the extreme, we have binary neural networks. It's our extreme in this process of quantization. So this is the normal way to do it. We do everything with floating points. So our weights are 32-bit floating points. Our activation, that is the result of our operations between layers, are floating points. We do everything with 32-bit floating points. Now we could store only our values, our weights, with, let's say, 4 bits, but now we dequantized and we do the all operation still in 32 bits. What we have gained here is the storage itself. Usually we call this simulated quantization, because we are not performing the operations in 4 bits. We are still dependent on a floating point unit. But a full quantized neural network, we would do everything with our quantized values. And here we would scale everything. Even the inputs would have to be scaled to our new scale of, let's say, 4 bits. And now we would do everything quantized. Okay, so we would quantize our inputs, whatever it is, an image, other sorts of signals. We would perform the multiplication and accumulation in 4 bits. The accumulation would have to have a little bit more bits, although we could quantize again to put it back and have the same length. Although the most usual is to do everything with 4 bits and then to accumulate with 8 bits, or do everything with 8 bits and accumulate with 16 bits, so that we have the result of the multiplication without the need of being quantized again. What I will show you is an example of the middle section. Here I will quantize, dequantize, and run it again. So, fault detection. Let's go through it. Let's do the process, the whole pipeline of a fault detection problem. I want to train a neural network and I want to deploy it on a wearable. What do we need to do? Well, firstly, let's say that our context is I have an accelerometer in my body. I am acquiring acceleration signals, 3-axis signals, acceleration, and based on this information, I want to detect patterns that would be representing a fall. So this is my case study. And I want to deploy it on a wearable. So if we are talking about measuring acceleration, the type of network that we use is the LSTM. The LSTM is used for time series. CNN, convolutional neural networks for spatial information, image and time series, like the acceleration that we are measuring, we will do it with an LSTM. This is the math behind an LSTM. I'm not going to give here much details, but this is the mathematical operations that we do. what I want to get from here is, what do I have to store? What are the parameters? What are the weights that I have to store? And this is the matrices that we have to store and their dimension. And when we are working with an LSTM, a decision that we need to do before starting the training stage is, what is the size of the LSTM? We call it the number of cells of the LSTM. In practice is, what is the size of the matrices that are storing the weights? Obviously, if I have a larger matrix, I will be able to have more values to adjust to detect my pattern. Okay. So the first thing that I'm going to do is I will use a public database. We have currently a lot of public databases with acceleration values and with falls. Obviously, the falls are simulated by someone falling, usually into some soft ground. So we don't have a perfect scenario for getting the training data, but it's the standard procedure to use a public database. And what I will do first is to consider two scenarios. One is to have two LSTM layers. So we will have our time series, that the acceleration signals that we are acquiring. It is normal to always start with a batch normalization to uniformize our values, and then apply it to some LSTM layers, where one layer is one set of those equations and matrices. We could do it with one or two layers. So we first scale it. We have the feature extraction that we will get from the LSTM. And at the end, the last layer will be usually a fully connected layer to obtain the classification classes. And we normalize the output so that we have an uniform distribution among the classes that we are considering. The problem that I will show you will consider only one LSTM. Now, if we want to deploy it on a wearable, we need to have some indication of what will be the size of my network in terms of memory occupancy, because depending on that, I will have to choose some processor to implement the neural network, and I need to have the necessary memory to do it. If we would stay only in our training and quantifying accuracy and just not going to the state of implementing the neural network, we don't care with those things, because we have a server with a lot of gigabytes of RAM and hard drive, and really we don't care. And when the memory is getting lower, we buy another hard drive, we upgrade some RAM, and we move on. It's not a concern. But if we want to put it on a wearable, we will have limited memory, we will have limited storage. So I will look to a memory model where basically I will sum everything that I have in my network, all the matrices that I am using that came from that mathematical equations that I have put with the neural network, and I will put this depending on the size of the LSTM. Okay, so I will have an L there And I will also be using variables like the number of bits that I am using to represent the neural network weights. And what we see is if I would plot with a 2D surface of considering 2 layers of LSTM, and if I cross-check with the memory size of common embedded processors, I have here an MPS 430. This is from Microchip, a very well-known lower power processor for embedded purposes. I have the CT8051 with the old architecture from Intel, the 8051. And if I cross-check, I will notice that, let's say, if I want to use an MPS from Microchip, the low power processor, I can only go and consider the same size for both the LSTMs. I can only go to about an LSTM with a size of 50 cells. So 50-50 in the 2 networks. Will that be enough? At this stage, I don't know. If I go to the 8851 architecture, it's a microcontroller from ST, I can go to around 100 cells for my LSTM. But once again, I cannot get from here. For these values, I am considering 80% of the total size of the memory of the processor. I'm putting only 20% for variables and management software that I will need. For the floating point. But now, if I consider 16 bits, so very simple quantization, the kind of quantization that forget all complex methods, just round it. It will work. I can go to about 80 cells of the LSTM for the MPS 430, and I can go with almost 200 cells for the 8051 processor. So just by performing a simple rounding of the values of the weights that I will obtain with training the neural network with 32 bits, I can go much higher in the amount of memory that will occupy my LSTM. So let's see what do we need exactly in terms of the LSTM size. So what I'm going to do first is I will train my LSTM, I will train my network considering several different sizes of the network, and I will plot it to see what is the accuracy that I am obtaining. And a training of a neural network is a stochastic process. So if I train 2 times the neural network, I will obtain 2 times different values for the accuracy. I can get almost the same values, but sometimes we can get huge differences between training. So it is recommended to do this, consider Monte Carlo and consider several simulations. And what I see here is that I will get a variation, but from, I would say, 20 for the size of the LSTM, I will get good results. So we can put this with our confusion matrices and look to the results. And what we are going to do here is I will consider to use 100 cells for my LSTM. Okay, And with that, now I will keep this confusion matrix because this is what I will want, besides the accuracy, this is what I will want to see regarding the quantization of my neural network. So now let's quantize. And when we are quantizing, I will once again cross-check the values here with the memory of my processors, the two processors that I am using here. So I have accuracy on the left side and of the left side, and I have memory footprint on the right side. And what I see here is with the processors that the 8051 or the STM, I can go to larger neural networks, but with more simple processor like the MSP430, I cannot go higher than 50 for the size of my neural network. So let's quantize. Let's do a very simple rounding with a scale. This scale will consider the intervals and the number of bits that I am quantizing, and simple math. Linear quantization, that is, I will distribute linearly the steps that I have with the integers, and I will do a round to the nearest integer. Just do a rounding procedure, and then we will do everything with the 32 bits floating point. So we will quantize to store with less number of memory footprints, and then dequantize to perform the operations. If we look to our weights, so this is the values that the histogram of the values that I want to quantize. And as I said earlier, we see that most of the values are centered in 0. 0 is something that we usually want to quantize efficiently, correctly. So we want symmetric quantization, because if I have so many values around 0, I want the 0 to be quantized correctly. So all the weights, these are the weights that I'm getting from the matrices that I showed on the model of the LESTM. They are also centered in 0, less one of them, the BS. The BS are not centered in 0. So what is happening there? Why don't I have a symmetrical distribution like the others? So basically, this is dependent of the gates. The LESTM, as I showed, has 4 gates: the forget, input, output, and the cell gate. And we have a different behavior intrinsically in the network, that the weights are being different. So here we are going to do something slightly different. We will separate them, and we will quantize, disclosuring the type of gate that we are using, so that we can center the weights in turning of the 0. And what we see here, 4 different confusion matrix, 16 bits, I have the same confusion matrix. So absolutely no degradation regarding the results of my neural network. Half the memory footprint, if I'm doing it with 16 bits, I have exactly the same confusion matrix. So I'm not getting any degradation. If I go to 8 bits, I have some degradation, there were 3 cases that shift sides in my confusion matrix, and it simply doesn't work with 4 bits or 2 bits. Because I'm saying that it doesn't work because, as you see, the number of cases in the false side is getting quite higher. But this is quantizing without looking to the gates. If we separate and treat differently the gates of the early STM size, what we get is that we have no degradation with 16-bit. We have no degradation until 4 bits. And I'm just doing a simple rounding on the integer values. Okay, I'm not doing any math with respect to the rounding procedure. What is happening here is that this is the values that we are quantizing. In red, we have the 32-bit values. Blue, we have the quantized values, so that have 4 steps there. And what we see is that when we quantize separating the gate values, they are more adjusted to their real value. So that's why we have absolutely no degradation with such number of bits. And now what we see here is we have the plots of the memory that will occupy the memory footprint of each quantization. And what we see is that now we can go with the processor, the STM88, that is a very simple 8-bit processor. 8-bit processor. We can perform fault detection with an LESTM of about the 60 cells. It will be more than enough to perform the good results with this fault detection problems. But if we consider other type of processors, we can go until the 200 cells of the LESTM. So to conclude, through quantization and doing very simple math on our neural networks, we can obtain similar results as using floating to 32 bits floating point. We will gain on latency, we will gain on memory footprint, we will gain on energy consumption. And we don't have to study a lot of math to doing a very simple task. Obviously, that if we have more complex networks and if we want to go to lower bit resolution, we have more complex ways to deal with the problem. Usually, what the state of the art would be to employ optimization to adjust the rounding procedure and to have a nonlinear scheme for the quantization. Basically, it's also empirical. If we put more intervals where we have more weights and we have less intervals where we have less weights, we supposedly will get better results. But my call here is, if we want to perform just until 25% of reduction of energy consumption, memory footprint in our networks, we don't have to work very hard, and we can very simply deploy our neural networks and start to say that we have a green neural network. This is very, we like to say this kind of words nowadays. So thank you very much for your attention, and I will end up here. Thank you.
Can I have a question? Because this is the purpose of this exercise, if time allows. May I? Yes. Can I, Sergio, can I call you Sergio?
Of course.
It's been a fascinating really talk. It's in my area. I've been using AI for the last 35 years. I've started my journey at Imperial. Actually, the field was signal processing, and nowadays I'm using computer vision, using AI, and exactly the scenario that you came up with. We're doing something for a government, exactly the falling object, in particular human being. Well, it's not really a question, it's a conversation. Of course, neural network and machine learning have served a hell of a lot of applications and improved quality of life. But we looked at different algorithms, let's say the topology, the learning algorithm, quantization, and so on and so forth. Don't you think now we need really to get out of this neural network and then get outside and call upon other agents really to be plugged in to really improve the performance of machine learning and neural network? We've come up with a lot of algorithms. Now it's been expanded to deep learning and everything, but we're still inside saying, okay, let's look at the number of hidden layers. Let's look at the I don't know, change the algorithm or whatever, but we're still inside. That was a discussion that I had with one of my colleagues at Stanford University. Why can we not step away? For instance, I'm doing a project, well, with the colleague for Lloyd's, and then we've been really training, we've been using a wide range of machine learning. The performance wasn't really satisfactory until we called upon feature engineering, and this has really improved tremendously the results. You see what I mean? So what are your views on this one? Does it make sense?
Can I, how long will the answer take is my first question.
1 minute.
Okay, go ahead.
No, I think I can.
Oh, perfect.
Well, I think that my answer will rely on my timeline, because this timeline, I would say that my last landmark, we are all alive. We were all alive in 2010. We are living this. We are not talking about something that is well established. For me, well established is something that I was not yet alive when it happens. I think we are living this era of artificial intelligence. I don't know if we are not presenting the birth of artificial intelligence. I don't know, but it's also fresh. You remember it, 2010 and GPUs. I was not born, but very short for the backpropagation algorithm. We are witnesses of the developments that are happening here. And that makes this fear maybe of considering it well established. That's my first thought. The second is when we rely on mathematical modeling and everything is true or false, and we have laws and we have very established rules, we believe very much on what we are doing. Artificial intelligence is empirical. You don't have fundamental science behind it. Why? Why do we use the number of layers? You won't find any theorem to tell you the number of layers of a neural network for this application should be A plus B dash C equals, you don't have it. It's empirical. So when we will have enough strength in ourselves to say this must be done exactly this way. So let's move on and let's go to the next step, like you were saying.
This cannot happen because if I think I can see where you're coming from, but unless we come with something universal that can apply regardless of the application, then yes, but it's extremely difficult if you see what I mean.
I think we are getting into the territory of long discussion and debate here.
Okay, now
You will have the opportunity to do that in the break, 1 o'clock to 2 o'clock, where both of you can carry on with this discussion. And thank you so much, Dr. Correa, and thank you, Karim, for an absolutely wonderful question, which would have taken this into a completely different direction, which I'm sure we'll all enjoy in the break session. So thank you, Dr. Correa. And I would, could I please ask Chris to present a certificate to our keynote speaker, a certificate of commendation to our keynote speaker. Dr. Correa, please. Professor Correa. I must say, I was completely blown away by the knowledge about quantization and neural networks that I learned today in this one session. And I hadn't had that knowledge in my entire lifetime, I would say. So on that note, I would like to finally invite our last but not the least, next keynote speaker, Aninda Bose. So Aninda Bose is senior editor at Springer India. He is responsible for publication of scientific books in the field of applied sciences, including topics on computational intelligence, communication, systems and security, intelligent computing, and energy. Over to you, Aninda. Thank you.
Good afternoon, and good evening to all of them who are hearing me from India at the moment. So good to see that people are physically attending lectures and conference is back to a room, you know. It was tough to see everybody online and virtually connect with people. But on the other note, you know, it's always good to see that people like Polkowski, Dr. Saru, Deepak, who are not able to join us physically, at least they are able to hear us, you know, sitting there and enjoying the conference. Thank you very much. You heard about the small history of ICDAM, which started in 2020, and we had a meeting in 2019, where this name was coined for the conference, and we started with it. Springer is associated with it from very first day, you know, and fortunately that it has grown to a level where we have almost 1,200 papers submission we have. It's an interesting scenario when we say 16% approval or acceptance. We have many good papers which we have to reject, actually. You know, honestly, I can tell you with 1,200 paper submission, the moment you have a scrutiny, it like comes to 600. With 600, it is very difficult to now take each and every paper out of that league. And being 190 papers which are selected over here, it's always good to see the collaborations which can take place during a conference. Thank you, the organizing team. And it is good to come back to LMU again. I was here, I was just talking to Chris in the morning, and I said I was here in 2018. And gave a presentation about a different topic on publication. You know, it's always very tough to select a publication topic, which is such a vast area. You know, people talk about indexing, people talk about bibliometry, there are so many things. Today, my topic is on publishing ethics and author services. There are two aspects to it. Publishing ethics is, we call it publishing ethics, but I personally feel it's actually ethics. nothing to do with research ethics, nothing to do with publishing ethics. It's all ethics. Ethics is the only word which should be applied to everything. And that comes from discipline, that comes from the character of a person. Second part is author services. Author services are, with technology coming into publication, right now we are publishing everything digitally. Everything is available in digital and electronic form. And there are lots and lots of tools which you can actually use. And our technology team sitting behind, they are creating these tools. Unfortunate part is, as a researcher, it at times very difficult for you to get to that tool and use that tool. You don't have that information because your desk is always filled with something else and you don't get an opportunity to go and look out for these tools. And there are so many of them. So I will try to highlight certain tools over here, which will be really helpful in your research work. The interesting thing is you can go, you can check. If it is useful, use it. If it is not, please discard it. That is a simple way of looking at it. So let's go into the presentation. A little about the organization I am coming from. It's started in 1842, almost the similar time when LMU started in 1848. And we are also, actually celebrating last year our 180 years. The name Springer is always, comes to your mind when there is a horse, you can see the logo which is there. But interestingly, now is the company Springer Nature, and Nature came from Macmillan Science and Education. So there is a big, many publishing companies coming under one umbrella and creating a big organization over there. So Nature started in 1869, Macmillan started in 1843. So all the people who are almost 200-year-old, they are coming together and they are forming this organization. It started as a small bookstore in Berlin by the person whom you can see over here, Julius Springer. We started publishing the works of Nobel laureates from very first day itself. And interestingly, the publication was very different at that point of time because now we have conferences, now we have indexing, people are coming, presenting, and immediately there's a paper coming in proceedings. That was not the case if you just go back 200 years ago, it was very different. There used to be a conference, no publication at all. People used to come, they used to discuss, they used to take back their review feedback, and they go back and they used to publish in a journal. So that scenario was very different. So we are coming from that part, but interestingly now things have evolved. We came out of Berlin very late in 1924 after the First World War, and we started with this office in Vienna. Dynamics were very different in Europe at that point of time. Our biggest editorial office is in Heidelberg, which is in Germany, which is also the place of printing, as you know. And we have a very big office in London at this point of time because Macmillan had a very big office, and now Macmillan is also a part of Springer. So we are one of the biggest office of Springer is in London, where I come from, where I am actually working right now. Few highlights, quick highlights, because numbers are always good pointers to focus on things. If you look at these numbers over here, you will see there's a 1.82 billion. It's a revenue. But interesting numbers are we publish more than 3,000 journals. We publish more than 13,000 books per year, which is a huge number of books. And we are working with 750,000 peer reviewers and 90,000 editors. Now, when we talk about this 750,000 peer reviewers, we are actually talking about 750,000 researchers. This is a very interesting industry where you have an author who writes, you have a reader who downloads and reads, and we have a reviewer who is basically reviewing their work, but they are all same people. They are not different people, The author, when he is writing, he's an author. When he is reading, he's a reader. And at the same time, the people who are doing research, all the faculties who are sitting here or the people who are doing research, they know very well. They get so many emails from publishers like us every day for the review work. Interestingly, you can only select some. You can give time to very few, but at the same time, the numbers are mind-boggling, This is something, the numbers which we have published, 410,000 plus articles in 1 year. So you can very well understand how many articles are there and how many submissions are there, because 70% articles are either they are in revision stage or they are rejected and going to the next year. So there's a huge number of work is there. And that is another data we can actually discuss and we can see. Coming to the topic directly, and this is the first topic of today's ethical issues. This is very close to my heart, so I always love to talk about ethical issues. What is copyright? You all know there is something called copyright. Copying is not right, but copyright is a term which creates a lot of issues. People who know copyright well, they know how difficult it was for the music industry at one point of time to maintain this copyright. Publishing industry is going through the same. I don't want to tell you about the definitions and all over here. What I want to highlight is basically the word COPE. COPE is an organization which is actually Committee on Publication Ethics. If you know about this, then fantastic. If you don't know, please go and visit their website. All good publishers are members of COPE. Whatever guidelines and policies we follow are actually aligned with COPE guidelines. And COPE is a platform where you can actually go and do a lot of connection, a lot of case studies are there. The policies are available in a very lucid language. So you get to know things very quickly, and new cases, which are like very critical or typical cases, are getting discussed over there on ethics. So COPE gives you a very good information. Coming to our digital world, as I said, now everything is so electronic, so digital driven and technology driven, that even the publication has changed a lot. Like in last 20 years, we have completely changed our submission processes. Everything is on a platform driven thing. You get to upload your paper, upload your figures, tables, everything, and you don't have to send anything in hard form or a printed form. It's all obsolete. But something which is important over here regarding ethics is retraction. Now, what exactly is retraction, which was non-existent when we were talking about our print world or hard copy world? This is something to completely do with the electronic world. When you publish a paper or a chapter or a book, in case there is any unethical activity we can find, there is a possibility that we can take down that paper, put a note over there very clearly, because of this reason, the paper has been retracted. That means we are taking away that paper. Paper actually remains there until and unless it's a big problem for the whole community. We don't take that paper away. It's there with a note very clearly mentioning about the retraction. Now, if you look at the reason, the first reason is very interesting. It says honest error. Now, what exactly is honest error? That means someone is committing that error, but they are not actually consciously doing it. They are doing it by mistake. And that is happening because we don't know the guidelines and policies well. And that is why I shown you the first slide about COPE, where you can actually go and find these policies. I will tell you about more information. My presentation is more like, like giving an assignment to you, where you have to go back, you have to go to these tools, you have to go to these pages, learn and read. And these are like reference material. You don't have to memorize anything. You have to come back again and again. When there is a need, you can come back. Rest of the reasons you can see very well. It's a fabrication and falsification. With internet coming over there, a lot of data is available now. So there is a data available for fabrication and falsification also. Redundant publication, that means self-plagiarism. That is also a part of little bit of honest error, because you are doing some kind of self-plagiarism, but you are not actually doing it consciously. Sometimes it's a mistake. And then there are other reasons. Simultaneous submission. Simultaneous submission is a very interesting thing. Sorry. Oh, it's not coming correctly. Anyways, simultaneous submission is basically submitting a same paper to different journals at the same time, submitting the same chapter to different publishers or a book at the same time. Now, why this is a problem? Because, see, you might say that I am just submitting the paper to different journals, but I am not publishing it. If I get an approval from 5 different journals, I will only publish with 1. I'm not going to give it to other 4. So why it is unethical? Unethical in the sense, because when we receive a paper from any author, the first thing, it goes to the journal editorial office. They check the paper with a checklist. If everything is fine, it goes to an associate editor of the journal, and it moves. Next step is going to the reviewers. Now, if you are submitting the same paper to 5 different journals are doing the same thing. So your paper is actually going to different reviewers, maybe sometime to the same reviewer. Because when we are talking about this whole thing, it's like peer review, peer review, right? Peer review is like sending the paper to your friends, and friends are like people who are working in the same area. So sometimes it's basically a waste of resources, and the resources are reviewers. As I said in the beginning, this is an industry where you have similar people are working on the areas. Sometimes it's very, very time consuming, and delays are there regarding publication because a paper is not getting reviewed properly. You don't have a proper reviewer. Maybe you are working on a very niche area, and the paper is not going to a person who is actually working in that area, but maybe on a bigger area. So sometimes there is an issue with that also. Plagiarism. You all know what plagiarism means. Plagiarism is a very derogatory word when we say it's like stealing someone else's work without giving recognition. But interestingly, we have synonyms in English. We know words like overlapping, we know words like similarity, and we use it very consciously. We write to authors. If you write to an author that your work is plagiarized, 80% plagiarized, or 40% plagiarized, the people will take an offense. But if you write someone, your work is 80% similar, they don't take an offense. They said, okay, I will change it. I will work on it. But interestingly, the thing is same. But so most important thing is you should give recognition to people from where you are actually using the work. Whether it's your own work, then also you take permission and do it. I will tell you how. But interestingly, there is something called fair use. And fair use, there is a document we have called Association of Fair Use. Basically, you can use that document, and that is available on Google, and you can use that. And that document will tell you what exactly is the fair use. Now, how are we alerted? I don't know why the presentation is not coming properly. There are some documents which are missing over here. How are we getting alerted? Another important aspect is basically how we get to know about plagiarism. It is like, interestingly, it is not coming over here. There are 3 pointers over here. Now, these 3 points are basically what? Firstly, we get to know from authors who are writing the paper. They go back and they tell us, my work has been stolen by someone else. It is somewhere, it is basically appearing. Second is by reviewers. Reviewers, very seldom they tell us the work is plagiarized, but they are reading so much into their area, they actually alert us there is something fishy going on. Thirdly is whistleblowers or readers who reads the same article at different places and tells us, oh, there is something, a problem is there. Now it says it cannot identify plagiarism. I don't know why the texts are missing over here. Anyways, what I want to tell you basically, when we use any tool, there are tools, right, for identifying plagiarism. What are these tools? Anybody knows that? Turnitin. Turnitin is the oldest one. Then you have Authenticate, that's from the same company. Then you have DocuLog, and then there are many. So obviously, these are very expensive tools. They issue licenses. Individually, it is very difficult to buy. So institutions and other organizations can only buy them. But what exactly you are getting when you are using these tools? When you are using them, you are getting a number, which is a similarity percentage. And these numbers are actually not giving you the correct picture at times, because that is why I said it cannot identify plagiarism. It can actually give you certain percentages. You need a human expert or subject expert to tell you whether the work is plagiarized or not. I'll tell you the reasons. Before that, this is how Authenticate looks, This is the inside story of Authenticate, where the papers are over here, you can see, and the percentages over here. See how beautiful and colorful this paper is. But interestingly, it is just 93% similarity it is showing with 39% single source. So it's highly plagiarized paper. Maybe this is a self-plagiarism only. So let's see the tips. What I want to tell you about, the tool cannot detect all problems. And why I'm saying this, a low similarity score does not mean there is no plagiarism. Interestingly, I'll give you an example. Suppose there are 2 papers, X and Y. When you run them on a tool, X gives you 30% similarity, Y gives you 10% similarity. Now, if you look at the numbers, it's clear that X is more plagiarized or more overlapping because it's shown 30%. And Y is 10%, it's S. But maybe it's a different story. If you go inside, you say this 30% is coming from 30 different sources, and they are just similar words or sentences in some papers, but this 10% is a direct lift in a particular section. Now, this 10% becomes more problematic than 30%. Individual scores also. Why? You have two papers, X and Y. X says 30%, Y says 30%. Now, X says 30% from 30 sources, Y says 30% from 2 sources. 15, 15 maybe, 10, 20 maybe. So Y becomes more problematic. So that is why I said, if looking at those numbers are not going to give you any clue which is more plagiarized and which is not, you need an expert, you need a human intervention over here to understand. Now, importantly, people will say, then what is the standard? How to go with these numbers and how to check them? Usually I tell them, like, if you are checking a paper and you are getting less than 20%, then you go and check the paper, quick glance, and send it to the reviewer. If it is more than 20 and less than 40, send it back to the author that please revise, revision is needed. If it is more than 40, then I don't think there is no need to publish that again. It's already 40% is out there. So it is better to write a new paper rather than replicating this old one. By participating publishers. This is also very interesting because Authenticate, Turnitin, Docolog, whoever organization is, they have a cross-check database. The internet. Whenever I am publishing in a digital form and I am a part of cross-check database is basically getting checked. If something is published in a hard copy or a print copy, then there is no possible way of checking that with your tool. Tell you another lovely anecdote over here. I was attending a conference in Udaipur in India from 6 years ago. So an author came to me and he said, sir, Google Translate is amazing. So I said, how come? He said, sir, you can translate anything which is in Mandarin, Spanish, or anything, and all these they never works. so that is another thing which is unethical. So that it's not an idea. Don't go there. So it's just way of telling you that is another unethical area. And a lot of Spanish papers are actually getting translated to English, and we are basically getting a lot of complaints over there. Common phrases, we have a lot of common phrases, we have common algorithms, we have definitions which are like needs to be part of your next paper also. But tool is not going to identify them. Only the person who checks the paper as a human subject expert can have taken permission for a text. But at the same time, when you have permission, so it is anyways going to highlight that. Again, you need to check. Patchwork plagiarism. This is dangerous, and people and publication. If you go and check on Google Salami publication, you will get to, you can read more. As I said, self-plagiarism. Self-plagiarism is another issue. It's actually publishing your own work, which is already there and which is not needed. So in case you are actually going to use substantial amount of your paper in the next work or advanced study, then it is better to refer them rather than putting the same text over there. Otherwise, a tool can show some 40% and immediately your work will be taken out and you will be penalized for not anything actually. Data fabrication and falsification, as I said, this is internet came and you have this problem cropped up because you have more data, things are available, people are doing it, stay away. So general advice, verbatim copying should be put into quotation marks. Suppose it's a single sentence or 2 sentences you are using from some place, then you can use some quotation marks, give credit to the original author. And if you don't know how to take permission, then it is like, first you approach author. If you author, sometimes they even don't know how to give permission to you. So it's better to go back to the publisher and do it. Write to the publisher. Publisher will give you permission to use that content again. And always take permission for using figures and tables. Whether it's your work, someone else's work, a single figure, even if you are using from your previously published work, take permission and then only use it. See, this is how we give you permission. This is simple. When you publish a chapter or a paper on Springer or with any good publisher, you have a home page, right, of that paper. In the home page down below, you always find there is something called reprints and permissions. And reprints and permission is the link where it will take you to rights link, where we ask some questions and you can answer them. If it is your own paper, then you don't have to pay any charges. But sometimes if it is someone else's work and you are using it for, suppose, for writing a new book where you are getting some kind of a royalty or remuneration, then there is a possibility that a price is taken from it. Come to the next section, author services and publishing tools. This is a tool, interesting tool, Journal Suggester. This is created by an organization called ICDAM. When they created this for us, we had around 2,500 journals, but now we have around 4,000, 1,500 plus. What exactly Journal Suggester is doing, how to find it, you go to our website, Springer. You will find services, and services you will find journal authors. Under journal authors, if you go to this page, you will find Springer Nature Journal Suggester. Springer Nature Journal Suggester has around 4,000 journals. What exactly it is doing, it will tell you how to even do. And website, it is basically having a portfolio of something around 32,000, database of 32,000 journals. And we have around 3,500. So you can go to ICDAM, also use the same thing, and that is also free to use. What exactly I have done is when you go to this link and you click, you go to the next page, it is actually asking about manuscript title, manuscript text, and subject area. And you can put a little more advanced details also. What exactly I've done, I have put a title over here, an old paper, Bose-Einstein condensation, a little bit of abstract over here. If you don't have the abstract ready, what you can do, you can put some key words of your paper. Not necessarily, don't put the keywords of the subject area because it is not going to search the correct, give you a correct search. Give the keywords of your paper, basically, where exactly you're working. Then I put the subject area of physics and I said, suggest journal. So the tool has suggested me around 20 journals over here. So without even going on asking anyone, you can actually use this tool and find journals which are available for your work. You go to the first one, click, go to the first one. It will tell you about what all details are there. If you find this interesting, useful for your work, you can submit your work. If you don't, go back to the list, check the second one. But easy way of finding journals which are basically selected for your work. How to find editors and people, that this is actually, it is very difficult at times for people to know how to go and search people. So easy way is search by subjects. You go to the website, you will always find subjects are aligned over here. Suppose you want computer science, it's over here. If it's mechanical engineering, go to engineering, you will find, and you can easily find people who are basically listed over there as editors and easy to connect with them. In case you are wrongly approaching anyone also, then there's a possibility that they will guide you to the correct person, but easy way to go is by subjects. Reviewer Finder. This is a tool which we have developed almost 6-7 years ago, because many journals are mandatorily asking for you to, give the names of reviewers when you submit a paper. So this is an easy tool where you can go and you can find reviewers who are working in your area. But I see a different use for this tool, because when you are looking for a reviewer in your area, what you are doing, you are looking for a person who is working in your area, in your domain, in your maybe practically in your area complete. So that person who is working in your area can be a collaborator. So this is a good tool to find networking rather than looking for viewers also. This is a page where you will find a lot of information about tutorials. This is again under services, because when you review first time, you really don't know what exactly you have to do. So you find a lot of checklists, a lot of videos available which you can make use of. And as an author also, you have to follow certain policies and guidelines. Those are over here. So if you go to this page, that will tell you, gives you a lot of information. But again, I'm telling this, you don't have to memorize anything. You need to know where exactly you have to find them. That's it. Another tool which was developed 5 years ago, shared it. If you publish anything with Springer, we are doing it for journal articles and for book chapters right now. If you publish anything with Springer, you get a small link when the publication is over, and that link is basically called shared it link. Now, how it works, interestingly, you can actually share your work with anyone who wants to read it. If I am coming from an institution and I don't have access to that work, at least I can download it, or I can get that link and read it. But it works in a different way also. As I said, suppose I am coming from an institution and I don't have the access, I can write to the corresponding author of that paper, please share it with me. So it's just a link sharing, and legally you are able to read and access the whole paper without even paying for it. ORCID ID. How many of you have ORCID ID already? Fantastic. Because this is something very much required, because for your unique identification, and especially with people having common names, they have a lot of problems because their citation moves from one here to there, and that is a problem. But with ORCID ID, nowadays, mostly journals are even asking for this, and it is already as a small symbol or icon, it appears in the papers also. So it's easy to get that. And if you don't have it till now, please go and register. This is a page, interesting page, springer.nature.com/in/policies. You will find all the policies over here. And these policies are not only publishing policies and editorial policies, but also research data policies, because we are using lots and lots of data in our work. So you have research data policies and open access publication policies, because now everybody is moving towards OA, open access, and you need to know open access policies well, your information correct about the licenses and all, so that you can publish it in a better way. There are funders available. I can tell you, under services, there are OA funders link. You can go to OA funders, and funding is available from almost 400 different funders. Some, they are doing it for only journals, they're doing it for only books, but definitely these informations are very important, because when you publish in OA form, you not only publish it in open, but you are reaching a huge number of researchers, and especially places where underdeveloped countries who cannot actually buy even if it's no first time, maybe a second time it's yes, why not do it rather than waiting for someone else to get that, fund instead of you. This is a blog post which we have created almost 6-7 years ago. Our backend team works in this, and there's always a possibility that you can also go and write your blogs over here. There's interesting blogs are available, so you can go and you can download, read, all open access. So there's no license, or you don't have to buy anything. There are 2 more blogs. If you go to this particular page, you can see more blogs which are available, like career-oriented blogs are there, where publication career and everything is basically a talking point. So, and in source also, there is a possibility that you can do networking, and you can have a platform where you can talk to different people who are basically submitting their work in these blogs. I will tell you about 4 books quickly. I think these are the reference material all researchers should have on their desk. To start with, this is a book which is 8th edition, 9th is out, and 7th is freely available. You don't have enough to buy this on internet. How to write and publish a scientific paper. This is started by Robert A. Day, and then Barbara Gastel joined him. And this is a fantastic book, which actually talks about all kind of writings which are there, and people who are writing for the first time, or they are already doing their doctoral thesis and all. This is an amazing thing where you can refer back again and again. And sometimes you have, as a senior person also, you have sometimes queries which are very difficult to get answers from. And these are the reference material from where you can get actually. This is another book, getting it published. This is actually written by a publisher himself, William Germano. This is talking about all the nuances of publication world, why there is a series editor, why there is a volume editor, what is royalty, what is patent, how it is different. It's like more of a glossary thing, which is available in this particular book, and you get to learn so many aspects. Again, a reference material. I talk about ethics, so I always go and tell you, recommend this book. This is a textbook in some universities. This is written by Sana Liu, but this is an interesting read, and it's a must read for people who are doing research.
And finally, this is a very new book written recently, Writing for Publication. This is talking about scholarly tools, actually. Click, yeah. Now, you all know 2015 is the year when we started with SDG and 17 goals, 169 targets. And all these 17 goals are very important goals. All the target was 2030, but I think we will be there 30% by that time. So 70% needs to be achieved after that. People who are working on SDG, this is a kind of a report which we are creating for last 5 years, driven by Discovery, is a 2022 report. And this is freely available. And you will get to know what exactly we are doing at Springer for SDG, and interesting area. We are working very heavily on certain areas like education, no poverty, and climate. That is SDG 13. Our teams are working regularly. We are able to reach that carbon net zero in some offices of ours, especially London is the first one. We have done it. And interesting report, read it and collaborate, If you are doing anything related to SDG, you can collaborate. So my message is very clear to people, when we talk about ethics and when we talk about all these things, work sincerely, focus on quality, say no to academic corruption. Unfortunately, academics still have corruption, which shouldn't be there when we talk about ethics and all. So stay happy and stay away from corruption. If you have any questions, I will be happy to take them when we are having lunch, because I'm standing between you and lunch. At this point of time, it's always difficult to give a final lecture before lunch or the next lecture after lunch, because then you will be sleepy after having a good lunch. This is my email ID, arindo.post@springernature.com. I know after using these tools, after reading them stuff, and you have queries, a lot of queries are there which are always unanswered because people don't have any answers for them, because people who are not from publication world, they are not related to that world. So write to us, write to me. I will be very happy to address them also. Thank you.
Thank you so much, Anindya. It was really wonderful to hear from you and learn so much about the publishing world and how copyright is fine, but copying is not right. I'll never forget that one.
Thank you. Thank you so much.
And could I please request Kareem to give a certificate to our keynote speaker?
Thank you. It's an honor.
So now,
Thank you. Thanks. Thank you. Thanks.
So thank you, Richa. Please. Thank you very much for joining. Although we have already done the vote of thanks, but still, I would like to thank the team members. We have some certificates for other people also. Zamil, please, if you can. First, I would like to invite Chris Lane. Yeah, please. Ma'am, if you can do the honor. She's our session chair also and an author also. Please, Chris Lane. Without his support, it would not have been possible. Under his able guidance, we made this conference a success. Thank you very much. So please, this is a small token of love for you. Thank you, please. And I would like to call Richa. She is associated with us from past 1 year, and she's guiding us. She's also a part of the promotion of the conference, and we all have seen that she was our showstopper. Thank you. Just a second, one more bag. Yeah, please. Now I would like to call Aninda sir, please. And I forgot to take the name of Professor Karim. My apologies for the same when I was speaking. So Professor Karim, thank you very much. And we all will be looking for the great support. Yeah, thank you so much. Please. Huh? Sir, so my really special thanks to Professor Balvirde, very humble. I would like to say that very humble person. And in past 1 year, my respect for him has grown a lot. And he's always available. He was always available for me, whether it was 12 in the night or in the morning. Whenever I I asked for any query with his team members, Richa and 2 other team members were also there. And Professor Bal, please, if you can come here. Thank you very much for the support. And without you, the conference would not have been possible. Yeah, please. Please, yeah. So I would take. So this is another.
Thank you so much.
So, yeah, please, Bal. So thank you very much. With this, we end the keynote sessions and the other ceremonies. So before ending this session, I have some thoughts about research. Means we all are doing so many conferences. We are part of wonderful conferences. But what I personally feel is that academics or the research has no boundaries. Because we have, in my past 3-4 years, as a universal innovator, this is one of the, universal innovator is one of the organization which is supporting the research. And apart from doing international conferences, we are also part of intellectual property rights, that is the patents. We have done one conference at India that is directly on the patents, where we published around 60 patents with Indira Gandhi Technical University for Women. That is one of the famous university in India. So what I personally feel is that in my team also, that research has multiple aspects. Like, what is research is? Research is something, as Aninda sir has already told us about, and we all have seen so many aspects about research, that research has multiple parameters. When something intellectual property is coming out of from our mind, that is not that properties of 2 types, that tangible or intangible. So anything which is intangible, something which is coming from our mind, is an intellectual property, and that need to be safeguarded. The most important point regarding research is that how a person, a particular idea which is coming from his mind, is going to be registered in a way. The base is same for everything. That is a research. Now, research can be anything. For example, if we are writing the research papers, it has a separate domain. Now, if the commercial angles are involved into it, that becomes a patent. So as far as the IPR is concerned, there are other aspects also, like we deal with copyrights, we deal with trademarks, we deal with trade secrets. There are many other aspects. And one more important aspect to the research is basically an startup. In 2020, we did one conference where we called upon the entrepreneurs and the research community. ICICC 2020, we did just before the COVID, where 22 startups got the funding. We did a proper program. And to the best of my knowledge, both the initiatives were unique, and I have not seen those initiatives. So with this platform, means I'm not saying that we have group of intellectuals, very wonderful people, very all are entrepreneur in my mind. So it's something like to give an idea that what we are doing, the kind of conventional conferences, we all in India, we say the teacher is a guru. Guru means anything which is emerging out of our mind. We are basically preparing the future. future students. So it's like that conventional conferences, if having multiple aspects like intellectual property rights, startups, because what is startup is? Startup is something where there is a gap. It is uncovering a particular gap and it has some commercial angle. So if we can bring the startup community, the intellectual property right community, and the researchers under one platform with the research, means research methodology, we all must have studied or understood the meaning of research. But if the skills of research can be applied to the IPR or to the startup, because why the startups are failing? The reason behind the failure of a startup is because the startup are not following the proper protocol. Obviously, we cannot teach an entrepreneur a research methodology course. But yes, this is an open question. This is an open challenge for all our researchers to make the research related course content in a way so that it can be used upon by the startup community. This way, directly we can help we can reduce the failure rate of startups, because out of 100 startup, only 5 to 10%, even 5 to 10% is a large number, according to me. This also goes for the patent also, because out of the 100 patents, if we are filing, only 1 to 2% of the patents are getting, they are published, but they are not getting registered. Okay, so with this, thank you very much. This was a small idea in my mind, which I would like, which I thought this is the platform which I should share with all the intellectuals. Thank you very much.
Thank you, Dr. Khanna. And the lunch is served in the lobby outside. We'll start promptly, it's served here, and we'll start our afternoon session promptly at 2 o'clock. Thank you, everyone.
Hello. Hello.
Yes, I'm here.
Satyam, am I audible?
Yes, sir. Yes, sir. You are audible.
Okay. On behalf of ICDAM 2023, I want to thank all the participants to be connected here in online mode. So this is for today. So we will be resuming for the day 2 tomorrow at 1:20 p.m. So all are requested to please rejoin us for the second day. We have a invited talk from Professor Alfredo from Italy, and then we have the sessions presentations. So kindly be connected tomorrow. Thank you so much for today. Okay, Satyam, you can close the meeting.
Yes, sir.
Sorry
Yes, sir.
to interrupt you, sir. Sir, my connection got disrupted that time, and I was presenting my PowerPoint presentation. What I can do, sir, I got only 5 minutes, out of which I only presented 2.5 minutes only.
No problem. You can send the PPT on the email ID, on our email ID. We will request session chair to consider your presentation. Okay.
Well, when how I get my email from your side, sir? How
The
can I
email
get
ID
email from
of the conference.
Okay, sir.
Okay. Okay.
Okay, sir. Thank you.
I'm sorry, I've got a question as well, if you allow me.
Yes, yes, please.
Presented yet? In session 6. So are we coming back at 2 and then we're going to be breaking up into break rooms?
How to?
So are we coming back at 2 p.m. today? After lunch break? Are we presenting after lunch break? So what time session 6 is going to present the presentations?
Today.
Yeah, what time today? Yeah.
Actually, for today, the presentations are already presented in online mode. Now, after lunch, there will be the presentation in offline mode.
I haven't presented. I was in the break room, but no one was there. What time was the presentations?
Your session number?
Number 6. My ID is 1040.
Okay, you have not presented your paper today.
Yeah, I haven't because I was at 9. I joined at 9 UK time.
Okay. You can do one thing. We will be having your presentation tomorrow, so you can just write to us on our email ID, and we will reschedule your presentation for tomorrow. We will send you the joining link on our email, and you can connect with us tomorrow for your presentation. Today, the presentations are over, and maybe due to time difference, you have joined late. So for tomorrow, we will send you the time for the session, and then accordingly you can join.
So we have finished for today, yeah?
Yes. You can just write to us on our email ID, okay? And then we will reconsider your request and reschedule your presentation for tomorrow.
Okay, thank you.
Okay, thank you.
Yes, please. I have a question. Yes, please. I am in session 2, 4, 7, 9. Yes. So what time I can present?
Your session is 2.
Yes.
And you also have not presented your paper today?
Yes.
Okay. You can also write to our email ID. You can also write to our email ID, and we will reschedule your presentation for tomorrow. Today's presentation is over. So
yes.
maybe due to time difference, you might have joined late. So for tomorrow, we are having the presentation after lunch. So we will let you know the timings for tomorrow and the meeting link. You can just write to us your paper ID and request us to consider for tomorrow.
Yeah, excuse me. Yeah, tomorrow I have to work, so I cannot. Yeah.
Okay, you cannot. So just write an email, and we will further communicate you with on the email. You can just write down everything on our email ID. Okay.
Yeah, so I want to know, yeah, today will be the present of which session?
Yes, session number 2. I think you are in session number 2. So no problem if you are not given the presentation. So you can just no. Actually, all the presentations are done for today. So we are just ending the meeting now. So you can just communicate us via email only. Okay.
Yeah, so I want to know.
Write an email, ma'am. Write an email to us regarding all the concerns.
Yes, thank you.
Okay, Satyam, you can close the meeting.
Yes, sir. Closing the meeting for everyone.